Welcome to the second video on the accounts payable audit. We're going to begin on page 132 of the IDEA workbook. Earlier in this exercise, as covered in the first video on this topic, we noticed that there were an unusually large number of payments between $70,000 and $80,000. There also are 3 payments greater than $100,000. We're going to take a closer look at these payments of interest. So what I'm going to do is make sure accounts payable is my active database, and the data property is selected, so we're looking at the accounts payable data. Now I'm going to do an extraction. On the Analysis tab in the Extract area, I go to Direct. For the first extraction, I'm going to call that one Unusual and High Payments. Notice up here that I'm going to include all of the records, and I'll select the ones that meet the criteria that I'm going to establish. So I will click on the equation editor. Now I want to point out something here that is not in the IDEA workbook. I am going to use parentheses that you did not see in the workbook. And let me explain what's going on. My unusual payments are the ones that fall between $70,000 and $80,000. The high payments are the ones that exceed $100,000. So let's begin writing. I'll put in an open parentheses, and I'm going to select amount. I want the amount to be greater than or equal to, and I'll type in the amount $70,000, but also I want it to be and the amount is less than $80,000. Now notice that I enclose that entire expression within parentheses. I'm just going to check and see if this part is valid. And yes, it is. So one condition would be that the amount falls between $70,000 and just under $80,000. The other condition would be an or. The amount, once again select amount, is greater than $100,000. In the workbook, you will not find these parentheses, but something that I always recommend is use parentheses to make sure we know the order in which the operators will be performed. So what I'm saying is the first thing we're going to do is the and here. We're going to check this entire condition. If you put the parentheses in a different place, you'll get a different result. Now there's a precedence of operators, and apparently in IDEA the and will be executed before the or. That's not something I'd ever want to rely on. So I always make use of parentheses whenever there could be a misunderstanding about which operation is going to take place. Okay, let's make sure we've got a valid equation. The whole thing is valid. And then I'll validate and exit. Let's go ahead and extract the records. All right, if you take a look, we can scroll down, but you'll see that these records are all either between $70,000 and $80,000, or there's just a few of them, they exceed 100,000. Here's one that exceeds 100,000, and here's two more that exceed 100,000. So we have extracted the data we want to look at. The control total matches what's in the workbook on page 134. We've got 87 records here, and that also matches what's in the workbook. Now there's a comment on the top of page 134 that there are a number of large value round sum amounts to supplier M100. We just noticed that as we look through the data. See, here we've got these $75,000. Let's scroll down. Notice how if I click on the column heading, we sort by that column. Yep, here's M100. It's also curious that the payee name is a little bit different in each case. Here we've got HMV. Well, we're going to have to look further. So let's go ahead and close the unusual and high payments database. We're back to accounts payable as our active database. I want to extract data where the payee name is cash, the amount is a round sum. I'm also curious about payments authorized by HMV, and I'm curious about payments made on a Sunday. So these all seem to be exceptions, and we want to take a closer look. Now in the middle of page 134, you see mention of Benford's Law. We're not going to be doing that at this time. We may cover Benford's Law later in the semester. There's going to be a lot going on at this point. We're going to do multiple extractions with a single pass through the database. We're going to use several different @ functions. So let's take a look at the bottom of page 134 in the workbook, payments with cash in the payee name. So again, accounts payable is the active database. I'm making sure that the data property is selected. We'll do another direct extraction. The file name for this one will be cash in payee name. I'll click the equation editor. Over here we've got various functions, and notice the ones that we're going to use here. This is in I, used to search for text within a character field, and this function is not case sensitive. The strip function is used to remove punctuations and spaces from a text field. So take a look at the top of page 135 in the workbook, because this is the function and this is the equation that we'll use for the extraction. So here it's a character function, is INI, and there's an explanation of that function, but I don't think I can. Let's move this around. Not case sensitive. The is in function apparently is case sensitive. If I click there, we get a little explanation. Yep, is in is case sensitive. Is INI is not case sensitive. So I want that function. I just double clicked. Okay. We've got to put in cash, all capital letters, enclosed within quotation marks. And let's go ahead and complete the equation. We're going to use this strip. There it is. Notice that strip removes all spaces, punctuation, and control characters from a text field. So I'll double click there. And what we're going to strip is the payee field. Now let me explain what this is doing. This is INI is looking for the character string cash in the payee field that has been stripped of all spaces, punctuation, and control characters. Let's make sure we've got a valid equation. It is. I will validate and exit, but I'm not going to run the extraction because I'm going to define more of them. Our next one, and this is in the middle of page 135, is round sum payments. So I'll click on my second line. I'll change the name to round sum amounts. And click on the equation editor. So we're looking for even thousands. We're given the equation near the bottom of page 135. I'm working with the amount field. The percent sign will do modular or modulo arithmetic. The modulus symbol in IDEA is the percent sign. So what we're doing here is converting the amount to $1,000, thousands of dollars, seeing if there's a remainder, and we want that remainder to be 0. Let's check it. It is valid. So what's going to happen here is we'll convert the amounts or look for amounts that are even thousands of dollars. So modulus arithmetic means you would divide your number by 1,000, the amount of the invoice by 1,000, and take a look at the remainder. So we're looking for situations where the invoice amount divided by 1,000 gives a remainder of 0. The invoice amount is evenly divisible by 1,000. That's how we're going to get these round amounts. Validate and exit. Now let's take a look at the top of page 136. We're going after payments authorized by manager HMV. So my third line here would be authorized by HMV. I'll open up the equation editor, and again we're doing some fancy things with string manipulations. You have similar functions in Microsoft Excel and in Microsoft Access. And frequently when you're doing data analytics, you would have to go through procedures like the ones we're going to do here. So let's take a look at that equation. We're going to use the upper function, which converts a character field to uppercase. I'll double click on that. And then what we're going to do is work with the authorization field, but I want to strip that field of spaces, punctuation, and control characters. So let me select the authorization field, and we're looking for situations where the authorization field is equal to, in all capital letters, HMV. Now again, this equation requires some explanation. Let me first of all make sure that it's valid. It is. Okay, I'm checking to see whether or not the initials end up HMV. In order to make that test, I'm first going to go through the authorization field and strip it of any spaces or punctuation, because sometimes it might be H period, M period, V period. And then I want to make sure that I won't miss it if it was entered as lowercase. So I'm going to force the stripped authorization field to be uppercase. And then I'm going to compare it and see if those initials are HMV. So I'll validate and exit. At this point, we've got 3 extractions set up to run. The next one is testing for payments processed on a Sunday. So I'll change the name here to Sunday Payments. And using the equation editor, I'm going to use the day of week function. So under date time functions, I've got day of week. One is a Sunday, 2 is a Monday, and so on. I'll select that function, and the field that I'm going to be testing is the pay date, and I'm testing to see if that is equal to 1, which would indicate a Sunday. It's valid, so I will validate and exit. I've got all 4 of these extractions defined. I'm going to run them in one pass of the database by clicking OK. So cash in payee name, round sum amount. Let me just move this around. Sunday payments, unusual, and high payments. And we can take a look at each one of these. Here's the cash and payee name. So notice that the word cash appears somewhere in the payee name. Anywhere in the payee name. Let's take a look at authorized by HMV. So see how we match periods or not. If they still show up. We didn't have any that were in lowercase, not that I can see. But if it had been entered in lowercase, we would have matched those as well. So we've got all of these authorized by HMV. Here's the round sum amounts. Okay, notice they're all even thousands. Curiously, these are all 75,000. A couple of them are zero. Those might have been canceled. Let's take a look at Sunday payments. Okay, these were all payments made on a Sunday. And take a look at the comments on the bottom of page 138. We're not going to cover Benford's Law in this video, so let's move ahead to page 149 in the IDEA workbook. Next, we're going to check for duplicate payments. So I'm going to make sure I'm in the right database. Let me close some of these others just to make the screen more readable. Accounts payables, the active database, I've selected the data property. I'll go to the analysis tab of the ribbon and look for duplicate key right here under Explore. Duplicate key detection. Notice we have to make a choice. We've got two radio buttons, whether we want to output duplicate records or output records without duplicates. For this test, we want to output duplicate records. On the top of page 150, we need to consider which field should be tested for duplication. You can test up to 8 fields. So I'm going to click on the key button. I'm going to select supplier number ascending and the amount of the invoice, and we'll look in a descending direction for that one. Let me say OK to that. I'm not going to specify any criteria other than the records being duplicates. And my file name will be duplicate payments. And in this duplicate key detection window, I'll click on OK. And here we have payments that may be duplicates. So we've got 3 payments of $75,000 to supplier number M100. We've got different invoice dates, different payment dates. The payee is different in each case. There are also 2 payments of $145 to supplier number P007. So we will have to follow up to determine whether or not these are duplicates, whether or not there's something questionable or even fraudulent going on. I'll go ahead and close the duplicate payments database. Let's go ahead and test for supplier numbers with multiple payee names. I'll go back to the accounts payable database. I'll go to duplicate key once again, and then exclusion. So the field that we're going to match is supplier number. The field that must be different is the payee. And my file name is going to be SUPNO for supplier number, multiple payees. Let's go ahead and run this test. So what we have is a set of records, a set of invoices where we've got the same supplier number but different payees. And we can go through this and do further analysis to see what's going on. On the top of page 153, we should have 120 records. That we do. And we've got a control total that matches what's in the workbook. So what's indicated here is that there's a weakness in the company's internal controls as far as maintenance of supplier information. We shouldn't be getting these different payee names. I'm going to close this database that we've been working with. Let's continue on page 154 of the IDEA workbook. The next thing we're going to do is to look for gaps in the check number sequence. To do this, we're going to use the gap detection task. So notice that the check field contains the check number. With gap detection, we can test for gaps in numeric or date fields or in a numeric sequence inside of a character field. If I just bring my cursor over the database and do a right click, one of my choices there is field manipulation. And this shows me the structure of my database. If we take a look at the check field, we see that it is indeed a numeric field. I'll close the field manipulation window by clicking on the Cancel button. From my Operations toolbar, I want to click on the Gap Detection button. So I go to the Analysis area of the ribbon. In the Explore section, Gap Detection. I'm now on the top of page 155. The field to use should be check. I could apply a criteria, perhaps just to look for checks within a certain date range. But I'm going to leave this at all. Starting and ending key values come from the maximum and minimum values in field statistics. I'll leave the gap increment at 1, but notice that that could be changed. I'll click on OK. So what we found are two gaps in the sequence. I'm at the top of page 156 in the workbook. So we're missing check 701805, and we're missing 4 checks numbered from 701-997, 8, 9, and 702-000. Now we could print these results if we wanted to. I could go up here and do a print preview if we like. And so here's a gap detection report. Again, you could print this, give it to the client, put it in the audit work papers. Let's close the print preview. Another possibility is to export to Excel. So we could just send the results here to Excel. But I'm simply going to go back to my accounts payable database. On page 159, we're going to look for gaps in the check date sequence. We're going to test for days on which there have been no payments. Once again, in the analysis area of the ribbon, I'll choose gap detection. The field pay date contains the payment date, so I'm going to select that. And I want to ignore weekends because we wouldn't expect to have payments most weekends. As a matter of fact, that might be a question. What does it mean if there's a payment on weekends? Previously, we identified 49 payments on Sundays. But for this test, we would expect there to be gaps over the weekends, so I'm going to ignore weekends. I'm continuing now on page 160 of the workbook. I'll also ignore holidays. Now you can set the dates to be ignored by clicking on the Set Holidays button, and we'll simply put in two of them. 0101, which would be New Year's Day, and 12/25, which would be Christmas. Once I have all of the holidays entered, I'll click on OK, and that takes me back to my gap detection window. For my result, I'm going to put pay date gaps. I'm not going to specify any other criteria for the test. We're looking at all dates. Notice here again, starting date value, ending date value come from maximum and minimum in field statistics. Click on OK, and there we see the date gaps in terms of missing days where there were no payments. We're at the top of page 163 in the IDEA workbook. I can save my gap detection results as a PDF file by clicking on this export icon. As we've seen earlier, we've got several choices for the export format: PDF file, rich text format that we can open in Word and other word processors, a web page, Microsoft Excel, or a simple text file. I'm going to leave it as Adobe Acrobat. I'm going to call it Date Gap, and I'll save it. Now that file is in my results folder under the project, and I can do whatever I want with that PDF file. So as you will see on page 164 of the workbook, There are 44 gaps in the sequence and 67 days on which no payments have been made. If I go ahead and browse over to my idea project, here we have accounts payable. Here's the results folder. That's the PDF file I just created. So we see the different gaps. It tells us there are 44 gaps and 67 missing dates. Let me close out of the PDF file. Get back to idea. Make accounts payable my active database and go to the data property. This concludes the second video on the accounts payable audit.